Hi, welcome. Today I'm going to take you through some guided solutions to questions on hypothesis testing. So without wasting much time, let's start. Question 1 says, which of the following is true? The t-distribution should be used whenever you want to use the t-distribution, the population standard deviation should be unknown. At the same time, the sample size should be small, that is, it should be less than 30. And also the sampling distribution should be normal. This means that for you to use the t-distribution, the sample size should be less than 30. At the same time, the population standard deviation should be unknown. Whenever you have a question and the population standard deviation is known and the sample size is less than 30, for that one, you still use the z. Also, when the population standard deviation is unknown and the sample size is more than 30, for that one too, you use the z. But for you to use the t, the population standard deviation should be unknown. At the same time, the sample size should be what? Should be small. And the sampling distribution should be normal. Okay. So the correct answer for question 1 is C. Let's proceed to the next question. Question 2 says, a real estate agent claims that the average price for homes in a certain subdivision is $150,000. You believe that the average price is lower. If you plan to test his claim by taking a random sample of the prices of the homes in a subdivision, the formulated set of hypotheses will be. Now, to answer this, first you write H sub 0, then you bring a column, okay? Then you write H sub 1 and then bring a column. Now go back to the statement. They said subdivision is $150,000. You believe that the average price is lower. You believe it is lower. So the word lower means less than, okay? And I told you in the introductory video of hypothesis test that whenever you have a statement of inequality, it goes for H sub 1, okay? Less than, greater than, and not equal to. Those three signs are statements of inequalities. They should go for what? H sub 1. So because lower means less than, and it is a statement of inequality, we are going to write it as H sub 1. Now, they said average. Average means the mean, okay? And the symbol for it is mu. So to write it, you write mu less than 150,000, okay? Now, what is the opposite of less than? Its opposite is greater than or equal to. So we write that for the H naught. So we write mu greater than or equal to 150,000. So you check the possible answers, which of them correspond to your answer. So it is D. So the correct answer for question 2 is D. Now, one thing about this is that the option C is totally wrong, okay? Even if the question confuses you, then you have between A, B, and D to choose. If you choose C, C is totally wrong. The reason is, when you watch the introductory part of the hypothesis test video, I said there that statements of inequality shouldn't go for H naught, and a statement of equality shouldn't go for H1. So when you look at option C has statements of inequality at H naught and equality at H1, which is absolutely wrong. So nothing should deceive you to pick option C. Option C is totally out of the box. Okay, so you have between A, B, and D to choose. Okay, so let's proceed to the next question. Question 3 says, the calculated numerical value that is compared to a table value in a hypothesis test is called the. Now to answer this, first, the table value, as in the z-score or the t-score or the chi-square score, that you check from the table, okay, is known as the critical value. Okay, so the table value is also known as a critical value, okay? But the question is not interested in this part. The question is interested in the calculated numerical value. Now, the calculated numerical value, or that's the calculated Z or T, the one you use formula for, it's called a test statistic. Okay, the test statistic. So the correct answer for question 3 is D. Please always check the possible answers well. if you see test statistics with S at the end, is wrong. Okay, the word is statistic without an S. So test statistic. Okay. So let's proceed to the next question. Question 4 says, a right-tailed test is conducted with alpha equals 0.0582. If the Z tables are used, the critical value will be. Now to solve this, first you have to check if it is one-tailed test or two-tailed test. Okay. Now whenever you have a question and the question says right-tailed or the question says left-tailed, it is one-tailed. Okay. So one tail has two types. It's either right or left. Okay. If it's not one-tailed, then they will say two-tailed. Okay. So first check out if it is a one-tailed test. So looking at this, this is a one-tailed test. Okay. A right-tailed test or a left-tailed test are known as what? One-tailed test. Because this is a one-tailed test, this is what you do. Now, depending on the table you are using, those of you using a full table, you say 1 minus alpha. Okay. So 1 minus 0.0582 will give you 0.9418. In case you are using the half table, then you say 0.5 minus alpha and you will get 0.4418. Okay. Now, after finding, if you are using a full table, when you take 1 minus alpha, then you go to the table. Now, the table at the left is the full table. Okay. And then the one at the right is the half table. So check your table. The full table has its probability value. The first probability value to be 0.5000. Okay. Then those using a half table, when you check your table, the first probability value is 0.000. That's the difference between them. Another difference between them is when you take the drawing at the top. For those of you using the full table, they've shaded your curve from Z to the left, the entire left. And then those of you using a half table, they've shaded your curve from Z just to half of the curve, not the entire left. So that's the difference between a full table and a half table. But provided you use them well, you end up getting the same answer. Okay. I'm only using positive table. Okay. So you got 0.9418. So for those of you using a full table, let's check it. 0.9418. So let's look out for it. At the middle, okay. 0.9418. So we have 0.9418. So we have 0.9418 here. Okay. This is 0.9418. So when you trace it to check the z-score that it corresponds to, you see 1.5 and there is 7 at the top here. So 1.57. Okay. It's 1.57. Now, for those using the half table, yours is 0.4418. So let's look out for it. 0.4418. This is 0.4418. So when you check it also, you see 1.5, then trace it up 7. So you see that we get the same answer. That is 1.57. So the question says right-tailed. So you have to choose positive 1.57. Okay. If the question had said left-tailed, you follow same procedure. After getting a z-score, you choose a negative answer. Okay. Z-scores can be negative, but probability values such as alpha and p-value cannot be negative. Okay. Yeah. So if the question has said left tailed, then you choose negative 1.57. But because the question says right tailed, you choose positive 1.57. Okay. Now also, if the question has said two-tailed test, for that one, you follow same procedure, but you divide the alpha by 2 before subtracting it from 1. And those of you using the half table, you divide your alpha also by 2 before subtracting it from 0.5. That's the difference. But because it is one tail, you don't divide the alpha, you subtract it straightforward. Okay. So the correct answer to question 4 is B. So let's proceed to the next question. Question 5 says, a right tail test is performed. The test statistic having a standard normal distribution. If the computed test statistic is 3.00, the p-value for this test is. Now to solve this, what you're going to do is you go to the table and then you check 3.00 at the z. So we have 3.00. So it corresponds to 0.9987. Okay. Now, This 0.9987 is not the p-value yet. Okay, you have to subtract it from 1. I mean, those of you using a full table, you subtract it from 1. For those of you using a half table, when you check yours 3.00, you have 0.4987. Also subtract yours from 0.5. Take 1 minus 0.9987, you get 0.0013. Okay, and those of you using a half table also, when you take 0.5 minus 0.4987, you also get same answer, 0.0013. Okay, so when you come to the possible answers, you see that they've written the answer for the half table over here, 0.4987, and full table. Be careful. You have to subtract this from 1, and those of you using the half table, you have to subtract this from 1. You get 0.0013. So the correct answer for question 5 is C. Now, because the question is a one-tailed test, okay, that is right-tailed, one-tailed test, that is why we pick 0.0013. If it were a two-tailed test, the p-value you get, as in after subtracting from either 1 or 0.5, you multiply it by 2. So if the question had said two-tailed test, we would have multiplied the 0.0013 by 2. But because it is a one-tailed test, you pick 0.0013. Okay. So let's proceed to the next question. Question C says, new software is being integrated into the teaching of a course with the hope that it will help to improve the overall average score for this course. The historical average score for this course is 72. If a statistical test is done for this situation, the alternative hypothesis would be, first, let's take the null and alternate hypothesis. Now, to write the null and alternate hypothesis, remember, I told you write H naught first and bring a column, isn't it? And then you come down and write H sub 1, and then you bring a column. Then you go back to the statement. It says, new software is being integrated into the teaching of a course. The hope that it will help to improve. When we say something improve, it means that it is greater. Okay, it is greater than or is more than. So when you improve something, you've made it more than that, or you've made it greater than. And remember, I told you that greater than or more than is a statement of inequality. Okay, so because it is a statement of inequality, which means greater than, we are going to write it as what? H sub 1. So we write P greater than 72. Okay, that is improve, more than. So what is the opposite of this? The opposite will be what? Less than or equal to. So we write P less than or equal to 72. Now, but the question only asks for the alternative hypothesis, not the entire set. Okay, so the correct answer for question 6 is D. So let's proceed to the next question. Question 7 says, Dr. J claims that 40% of his college algebra class, that is a very large section, will drop his course by midterm. To test his claim, he selected 45 names at random and discovered that 20 of them had already dropped long before midterm. The test statistic value for this hypothesis test is, now whenever a question asks you for test statistic, it means they want you to compute a z. Okay, they want you to calculate. Okay, so to solve this, when you look at the question, it says Dr. J claims that 40% of his college algebra class will drop his course by midterm. So this is a proportion, and this is a population proportion. Okay, this is a claim he makes about the population. So it's a population proportion, 40%. But when you go further, it says, to test his claim, he selected 45 names at random and discovered that 20 of them had already dropped long before midterm. So we can find a sample proportion from this information. Okay, to find a sample proportion, which is p hat, okay, it should be number of those who have dropped the course, which is 20, divided by the sample size of 45. Okay, so we are going to have p hat to be equal to 20 over 45, and that will give us 0.44. in 2 decimal places. Okay. To find a z-score, then we recall the proportion formula for z, which says z should be equal to p hat, that's sample proportion, minus p, which is population proportion, divided by square root of p times q. 1 minus p is also q, okay, divided by sample size n. Then we substitute into the formula. So let's substitute. Our p hat is 0.44 and the p is 0.4, that is 40%. Convert it to decimal, that's 0.4. 40 divided by 100, okay. So 0.40, 0.4. Then divided by square root of, we have p here, please be careful. Under the root, it is not p hat, it's rather p, okay. So 0.4 into brackets 1 minus 0.4 divided by the sample size of 45. So when you put this on your calculator, you get 0.5477. Now when you look through the possible answers, you see that your answer is not in. The reason is that when you find 20 over 45, the answer was 0.44444, isn't it? Because you've approximated the answer, that's why we are not getting the exact answer at the end. So go back to your calculator and edit it. Change this place to 0.44444 or put the entire fraction there. That is 20 over 45. Okay, put 20 over 45 in place of 0.44 and enter and see. When you do it well, you get A as your answer. That's 0.6086. Okay, so that is the correct answer for question 7. So let's proceed to the next question. Question 8 is, in testing a hypothesis, the hypothesis that is assumed to be true is... Now, whenever we are testing hypothesis, we always assume that the null hypothesis is what? It's true. So the correct answer for question 8 is B. Okay, we assume that the null hypothesis is true until we get evidence to prove whether it is actually true or not. But at the first place, we assume it is true. So it is the null hypothesis. Okay. Question 9. A type 1 error is defined to be the probability of... Now, the correct answer for this is D. When you reject a true null hypothesis, you've committed type 1 error. Now, the question is wrong. The question is not supposed to say probability. Okay, this word probability is not supposed to be in, because type 1 error is just the act of you rejecting a true null hypothesis. Okay, then let's proceed to the next question. Question 10 also says, a type 2 error is defined to be the probability of... Type 2 error is not a probability, it's just an act. So this word probability shouldn't have been in the question. So those who typed this question in the past made mistake. Okay. Now, the correct answer for this is B. When you fail to reject a false null hypothesis, the null hypothesis is false, and you fail to reject it, you've committed type 2 error. Okay. Then let's proceed to question 11. Question 11. In hypothesis testing, the level of significance is the probability of... So the correct answer for this is D. It is the probability of rejecting a true null hypothesis. If you remember question 9, do you remember that we choose same answer for question 9, rejecting a true null hypothesis? But question 9 says type 1 error is the probability of, and I said the word probability there shouldn't be there. This is the reason. Level of significance rather is the probability of rejecting a true null hypothesis. But type 1 error is not a probability, it is just the act, ACT, okay? It is just the act of rejecting a true null hypothesis. The level of significance is the probability of rejecting a true null hypothesis. I hope you get it. Listen, type 1 error is just an act, it is not a probability. It is just an act of rejecting a true null hypothesis. The level of significance rather is the probability of rejecting a true null hypothesis. That was why I said in question 9 that the word probability shouldn't be there. Okay, so be very careful with that. So I can also define level of significance as the probability of committing type 1 error. Okay, It is the probability of committing a type 1 error. Okay, then let's proceed to the next question. Question 12 says, the level of significance can be any. The correct answer for question 12 is C. The level of significance is a probability value. And you know probability is between 0 and 1. So the answer is C. Let's proceed to the next question. Question 13 says, which of the following general guidelines is used when using a p-value to perform hypothesis test? The correct answer for question 13 is D. Please write A, B, and C down. These three guidelines are used when we are performing hypothesis testing. If p-value is greater than 0.1, we say there is little or no evidence to reject the null hypothesis. But if the p-value is between 0.01 and 0.05, then we say there is moderate evidence to reject the null hypothesis. Then, if p-value is less than or equal to 0.001, then we say there is very strong evidence to reject the null hypothesis. So that A, B, and C are all correct. So that's why I choose D, all the above. Okay. Question 14. If you fail to reject the null hypothesis in the testing of a hypothesis, then the correct answer for question 14 is D. There is insufficient evidence to claim that the alternative hypothesis is true, because the question only says if you fail to reject the null hypothesis in the testing of hypothesis. The question is just telling us the decision. It's not telling us whether the null hypothesis is true or not. So because the question is not telling us whether it is true or not, the question is incomplete. So therefore, there is insufficient evidence to claim that the alternative hypothesis is true. So we choose D as our answer for question 14. So let's proceed to the next question. An advertisement on the TV claims that a certain brand of tire has an average lifetime of 50,000 miles. Suppose you plan to test this claim by taking a sample of tires and putting them on test. The correct set of hypothesis setup is, to write the set of hypotheses, first you write H sub 0 and bring a column. Then you write H sub 1 with your column. And then you go back to the statement. They said has an average lifetime of 50,000. When you put this in another statement, you can write it as an advertisement on a TV claims that the average lifetime of a certain brand of tire is 50,000 miles, isn't it? So has an average lifetime of 50,000 miles can also be written as average lifetime is 50,000 miles. It's a statement of equality. It's okay. Has. Okay. So because it is a statement of equality, remember I told you whenever you have a statement of equality, you write it at H sub 0. Okay. So because it's a statement of equality, we just write it there. So we say mu is equal to 50,000. So what is the opposite of equal to? It is not equal to. So we write mu not equal to 50,000. So the correct answer for question 15 is C. Now, nothing should deceive you to pick D. If anything will confuse you on this question, then you should choose between A, B, and C. D is totally wrong, because when you look at D, this is a statement of inequality at H naught, and this is a statement of equality at H sub 1. I told you that you should never have a statement of inequality at H sub 0. It is totally wrong. Okay, so let's proceed to the next one. Question 16. If we were testing the hypothesis H sub 0 for mu equals mu naught versus H sub 1 mu greater than mu naught, where mu naught is a specified value of mu, such as 50, 20, 100, at a given significance level alpha, with large samples and unknown population variance, then H naught will be rejected if the computed test statistic is. Now, to reject H naught, okay, first check if it is a one-tailed test or a two-tailed test. Okay, now when you check this, to know if it is one-tailed or two-tailed, you have to come and check the H sub 1 or H sub A. Now, whenever you have a greater than sign there, it is one-tailed test. Okay, if you have a greater than sign or a less than sign, it is one-tailed. Okay, But if you have a not equal to sign, it is two-tailed. So because this is one-tailed test, okay, then your answer should be A. Z should be greater than Z sub alpha for you to reject the null hypothesis. The null hypothesis, which is H naught, will be rejected if Z is greater than Z alpha, Z sub alpha for one tail. Okay. But if it is two-tailed, then it should be Z greater than Z sub alpha over 2. Okay. So if the question were to be two-tailed, you choose C. But because it is one-tailed, especially positive one-tailed, which is greater than, you choose A. Okay. So let's proceed to the next question. Question 17. A statistics student was not pleased with his final grade in his statistics course, so he decided to appeal his grade. He believes that the average score on the final examination was less than 69 out of possible 100 points. So he believes that it was an unfair examination. He thinks that he should have made at least a grade of B in the course. He decided to test his claim about the average of the final examination. If he knows his statistics, the correct set of hypotheses he will set up to test his claim is, now to write this, we write H sub 0 first and bring a column. Then we write H sub 1 and bring a column, okay. Then you go back to the statement. They said it was less than 69. Less than 69, okay. Less than is a statement of inequality, okay. So because it is a statement of inequality, we are going to write that H sub 1. So we write mu less than 69, okay. So what is the opposite of less than? It is greater than or equal to, isn't it? So we write greater than or equal to at H sub 0. So when you check the possible answers, the correct answer for question 17 should be B. Okay, mu greater than or equal to 69 for H naught, and then for H1 is less than 69. Take note of this also. B is absolutely wrong. It's totally wrong. Okay, it's out of the box because you have a statement of inequality at H naught and equality at H sub 1. It is totally wrong. If you make a mistake, then your mistake should be you choosing either A or C, but not D. D is totally out of the box. Okay, so let's look at question 18. It says, when a p-value is used in testing a hypothesis, we will not reject the null hypothesis for a level of significance alpha when, now, in the introductory part of hypothesis test video, I gave you the decision rule that whenever p-value is less than or equal to alpha, we reject the null hypothesis. And I also told you that when p-value is greater than alpha, we do not reject the null hypothesis. So when you look at this, they say we will not reject the null hypothesis for a level of significance alpha when the correct answer should be when p-value is greater than alpha. Okay, so the answer should be B, but they've made a mistake in the possible answers. There's no equal to sign for it. It should just be greater than alpha. It is rather this, when you reject, that it should be less than or equal to alpha. So to reject the null hypothesis, it should be less than or equal to alpha. And then to fail to reject the null hypothesis, the p-value should be greater than alpha. It shouldn't have the equal to. Okay. But if you see this mistake in exams, just pick the B. Okay. So let's proceed to the next question. Question 19 says, a local newspaper reported that at least 25% of the population in a university community works at the university. You believe that the proportion is lower. If you selected a random sample to test this claim, the appropriate set of hypotheses will be. So to write this, you write H sub 0, you bring a column, then you write H sub 1 and bring a column, okay. So you go back to the statement, it says, the local newspaper reported that at least 25% of the population in the university community works at the university. So it says at least. At least means greater than or equal to. It's a statement of equality, okay. At most means less than or equal to, which is also a statement of equality because they contain equal to sign. Okay. So at least means greater than or equal to. Okay. So since at least is a statement of equality, we are going to write it at h sub 0. Okay. So we write p greater than or equal to 0.25. 25% means 25 divided by 100. That's 0.25. Okay. And you can just write the opposite of this. That's greater than or equal to. Its opposite will be less than. So you just write it for h sub 1, and that will be p less than 0.25. Now when you go back to the question, you can also see somewhere they said proportion is lower. Lower means less than, which is a statement of inequality. So if you are not able to detect this, you should be able to detect this. Lower, less than, isn't it? And less than should go for inequality. So you see that it matches it. Less than is at the h naught. And less than is inequality, isn't it? Which should go for h sub 1. So when you look at it, you see that what we did also match that. Less than is at h sub 1. You see that. So the correct answer for question 19 is D. Now here too, nothing should deceive you to pick option C. Option C is totally out. Okay. This is an inequality at h sub 0. It's totally wrong. So let's proceed to the next question. Question 20 says, what will be your conclusion if the null hypothesis is a claim and the decision is to reject the null hypothesis? Now, whenever the null hypothesis happens to be the claim, okay, and you decide to reject the null hypothesis, you have to conclude that there is enough evidence to reject the claim. So the correct answer for question 20 is C. Okay, there is enough evidence to reject the claim. You can write it down. Okay, whenever the null hypothesis is the claim and the decision is to reject the null hypothesis, then you have to conclude that there is enough evidence to reject the claim. It can also be there is sufficient evidence to reject the claim. Another word for enough is sufficient. Okay. Question 21. What will be your conclusion if the null hypothesis is a claim and the decision is to fail to reject the null hypothesis? The 20 was to reject, but this one is to fail to reject when the null hypothesis is a claim. The correct answer for question 21 is D. Okay, there is not enough evidence to reject the claim. When the null hypothesis is a claim and you fail to reject it, you have to conclude that there is not enough evidence to reject the claim. 22 says, what will be your conclusion if the alternative hypothesis is a claim and the decision is to reject the null hypothesis? This time around, the alternative rather is a claim and you've decided to reject the null hypothesis. Whenever you have this case, okay, the correct answer for this should be A. There is enough evidence to support the claim. Whenever the alternate hypothesis rather is a claim, and then you reject the null hypothesis, you have to conclude that there is enough evidence to support the claim, or there is sufficient evidence to support the claim. Okay, 23. What would be your conclusion if the alternative hypothesis is a claim and the decision is not to reject the null hypothesis? Now, if the alternative hypothesis is a claim and you fail to reject the null hypothesis, you conclude that there is not enough evidence to support the claim. So the correct answer for 23 is B. Okay, there is not enough evidence to support the claim. 24. A local newspaper claims that 15% of the residents of the community play the state lottery. If you plan to test the claim by taking a random sample from the community, the appropriate set of hypotheses is. Now, to answer this question, first you write h naught, okay, h sub 0, and bring a column. And then you write h sub 1 and bring a column, okay. Then you go back to the statement. It says, a local newspaper claims that 15% of the residents of the community play the state lottery. You can change this statement. Now, you can change this statement to the local newspaper claims that the proportion of the residents of a community that play the state lottery is 15%. So you see that it's a statement of equality. Okay. So because it is a statement of equality, we are going to write it at h sub 0. So we write p equals 0.15. 15% means 15 divided by 100. That is 0.15. Okay. So what is the opposite of equal to? It is not equal to. So we write p not equal to 0.15. So the correct answer for question 24 is C. Please, D is totally out of the box. It's totally wrong. 25. A local newspaper claims that no more than 5% of the residents of the community are on welfare. If you plan to test the claim by taking a random sample from the community, appropriate set of hypotheses is. Now to solve this, first you write h sub 0 and bring a column, okay, and then you write h sub 1 and bring your column. Then you go back to the statement. It says the local newspaper claims that no more than 5%. Please, the word is not more than. The word is no more than or not more than. Now, more than means greater than, okay, but not more than or no more than means less than or equal to. If I say you are not more than 5, it means that you are 5 or less. It means you are less than or equal to 5. So it's a statement of equality. So because no more than is a statement of equality, we are going to write it at h sub 0. So we write p less than or equal to 0.05. 5% means 5 divided by 100. That's 0.05. Okay. So what is the opposite of less than or equal to? It should be what? Greater than. So we write p greater than 0.05. So the correct answer for question 25 is A. Please, for question 25, option D is totally out. It's totally wrong because you have a statement of inequality at h sub 0. Okay. 26. For the following information, n equals 16, mu, which is population mean, equals 15, x bar, which is sample mean, equals 16, and sigma square, this symbol is called sigma. Sigma square equals 16. Now, whenever you see sigma and there is a square on it, it means population variance. Okay. And then if you see S, small letter S with a square on it, it means sample variance. Okay. And also, when you see sigma without a square on it, it means population standard deviation. And then when you see small s without a square on it, it means sample standard deviation. Now, the question is saying that assume that the population is normal and compute the test statistic if you were testing for a single population mean. So to compute the test statistic, first you need to know whether you are going to use Z or T. Okay. Now to know whether you are using Z or T, first you can check out the variance or standard deviation, or you can decide to check the sample size first. Okay. Now when you check the sample size, you see that the sample size is less than 30, which is small sample size. But for this, you can't tell yet whether it should be Z or T. That's not enough evidence. Then you come to the standard deviation or the variance. If it is a population one, you are going to use a Z, not the T. For you to use T, the sample size should be less than 30. At the same time, the standard deviation shouldn't be a population, but rather sample. And the variance, okay, the variance should be a sample one. The variance or standard deviation, you get it. So when you look at this, the variance given is a population one. Even though the sample size is less than 30, the variance given is a population variance. So because it is a population variance, we are going to use Z. Another way to know if you are using Z for this particular question is that all the possible answers are in Z. So you should know you are using Z. So the formula for Z is x bar minus mu divided by standard deviation over root n. So we are going to substitute each value here. Now we know the x bar to be 16, so we put it in place of 16. We know the mu to be 15, then we put it there. Now, do we know sigma? We rather know sigma square, which is the variance. Okay. Now, since you know the variance, you can find the standard deviation yourself. So, by taking square root of the variance. So, square root of 16 will be the standard deviation here. Okay. Then, divided by root, n is 16. So, we substitute it there also. So, we are going to have 16, which is x bar, minus 15, which is mu, all divided by Now when you take the square root of the variance of 16, you get 4. So we substitute 4 here, divided by root n, which is 16. So root 16 will give you 4. 4 divided by 4 is 1. 16 minus 15 is 1. 1 divided by 1 will give you positive 1. You can put everything on your calculator. You get positive 1.00. So the correct answer for question 26 is A, 1 or 1.00. Okay. 27. Now for 27, we have same information. Okay. But this one says if you are performing a right-tailed test for a single population mean, then, so it looks like this question wants us to find a p-value. Now to find p-value, first you need to find the z. You need to calculate the z. Okay. But because question 26 is the same as this, and we already know our z from question 26 to be what? 1.00. Then we just go and check the table. So we come to the table and check 1.00. So this is 1.00. 1.00 will give us 0.8413. That is those of you using the full table. Okay. So you subtract this your 0.8413 from 1. So you have 1 minus 0.8413. When you take 1 minus 0.8413, you should get 0.1587. Okay. To those of you using a half table, when you check 1.00, you will get 0.3413. Subtract yours also from 0.5. You get the same answer, 0.1587. Okay. So the p-value will be equal to 0.1587. So the correct answer is C. Okay. Now, the question says if you are performing a right-tailed, so it is one-tailed. That's why we choose this as the answer. Okay. If it were two-tailed, you will multiply the answer you get for the p-value by 2. If it were two-tailed, then you take 0.1587 times 2 to get a p-value. But because it is one-tailed test, what you get after your subtraction is just the answer. Okay. 28. Now, question 28 also gives us same information. Okay. But it's asking us a different question. It says, if you are performing a right-tailed test for a single population mean, then you A will reject the null hypothesis if alpha equals 0.1. B would not reject the null hypothesis if alpha equals 0.1. To answer this, first, what was our p-value from question 27? Our p-value was 0.1587, isn't it? Now remember the rule I gave you about this. You can write it down. I told you that whenever the p-value is less than or equal to alpha, you reject the null hypothesis. When the p-value is greater than alpha, you do not reject the null hypothesis. Okay. So when you look at the alpha given here, it is 0.1. Compare it to the p-value. You see that your p-value of 0.1587 is greater than alpha of 0.1. So because it is greater, you are not going to reject the null hypothesis. So when you check the possible answers, you see that option B matches your choice. Okay. It says we will not reject the null hypothesis if alpha equals 0.1. Yes, that is true. Because our p-value is 0.1587. So if alpha happens to be 0.1, since our p-value is greater than alpha, we will not reject the null hypothesis. Question 29. Question 29 also gives us same information, but this time around they've changed the alpha to 0.2. So let's see how to answer the question. Now remember, our p-value is 0.1587, isn't it? Compare it to the alpha here. You see that it is less, isn't it? 0.1587 is less than 0.2. So because it is less, this time around we are going to reject the null hypothesis. So that's why the correct answer for question 29 is A. We reject the null hypothesis if alpha equals 0.2. Question 30. If a null hypothesis is rejected at 0.05 level of significance for a two-tailed test, now to answer this question, this is how to answer it. First, you need to know that when you have a 99% level of confidence, it means that the level of significance is 1%. That's 0.01. And then when you have a level of confidence of 90%, it means that the level of significance will be 10%. That's 100 minus 90. Okay. When you convert it to decimal, you get 0.1. Now, 96% confidence means alpha is 4%, okay, which is 0.04, okay. Now, to answer this question, it says, if a null hypothesis is rejected at 0.05 level of significance for two-tailed test, you always reject it at 90% level of confidence. So the answer is B. That is 0.10 level of significance. Okay. 0.10 is more than 0.05. Please, it's not a p-value, it's also level of significance. Whenever you reject a null hypothesis at a certain level of significance, it means that at any level of significance greater than that level of significance, you still reject it, no matter what. But any level of significance lesser than that particular level of significance, you can't tell whether you will reject it or not, unless you have the exact values. 31. For a left-tailed test concerning the population proportion with sample size of 203 and alpha equals 0.05, the null hypothesis will be rejected if the computed test statistic is... Now, to solve this, first, you find the critical value. Now, to find a critical value, check the question. It says left-tailed, so you should know it's one-tailed test. So if you are using a full table, you take 1 minus alpha, and that will give you 0.9500. And then if you are using the half table, you take 0.5 minus alpha rather, and that will give you 0.4500. Okay. Now remember, we say 1 minus alpha or 0.5 minus alpha because it is a one-tailed test. Left-tailed test is also known as one-tailed test. Okay. If it were a two-tailed test, we would have divided the alpha by 2 before subtracting. But because it is a one-tailed test, you subtract straightforward. Okay. So we go to the table and check 0.9500. So when you look for it, you won't get exactly 0.9500, but you get 9495 and 9505. It means that 9500 is between them. So because it is between them, you take the z-score of 9495, which is 1.64, and then you take the z-score of 9505, which is 1.65. Then you add them together and divide by 2. Okay, so 1.64 plus 1.65 divided by 2, that will give you 1.645. Okay, to those of you using a half table, you will check 0.4500. So when you check, you won't get it also. You get 4495 and 4505. So yours too is between it. So when you check, you see 1.64 and 1.65. Add them together and divide by 2, you get same answer. So 1.645. Now, because it is a left tail test, then you attach a negative to it. So that will be negative 1.645. So negative 1.645 is here. But we can't tell yet if C is the answer. Let's check something. We said the null hypothesis will be rejected if the computed test statistic is... Now, if your computed test statistic is less than the critical value, then you reject the null hypothesis. For a negative, be very careful. If the critical value is a positive answer, for that one, it has to be greater than, okay, the absolute Z. Okay, the positive z-score has to be greater than the positive critical value of z. Then you reject the null hypothesis. But in terms of negative, it has to be less than the critical value rather. But in terms of positive, it has to be greater for you to reject. So the correct answer for question 31 is C. It was reported that a certain population had a mean of 27. To test this claim, you selected a random sample of size 100. Computed sample mean and sample standard deviation were 25 and 7 respectively. Answer 32 to 35 with this information. Now 32 says, the appropriate set of hypotheses for the test is... Now, to write the set of hypotheses, first you write H sub 0, then you bring a column, then you write H sub 1 and bring a column. Okay. Now when you go back to the statement, it says, it was reported that a certain population had a mean of 27. Okay. To test this claim, you selected a random sample of 100. Okay. It means that the mean is 27, so it's equality. Okay. So we write it at H sub 0. So we write mu equals 27. Okay, not P, mu. So mu equals 27. So what is the opposite of equal to? It is not equal to. So it should be mu not equal to 27. Okay. So mu equals 27, mu not equal to 27. Now, when you check the possible answers, you see B to be the answer. So the correct answer for this is B. Please, D is totally out of the box. Okay. It's not always that they will put it at D. It can be at A also. Always check. This is not an equality statement, so it shouldn't be at H0. So it's totally out of the box. Okay. 33. The computed test statistic for the test is. Now to find a test statistic, first you need to know whether you are using Z or T. Now to know whether you are using Z or T, first you can check the sample size. When you look at the sample size is 100. Anytime your sample size is more than 30, even without checking the type of standard deviation you've been given, as soon as your sample size is more than 30, or let me say more than 29, the rule is n greater than or equal to 30, you are going to use Z. So the formula for Z in terms of mean, not in terms of proportion, is x bar minus mu divided by standard deviation over root n. Okay. Now, we are going to substitute its values. Now, we've been given sample mean to be what? 25. And sample standard deviation to be 7. So we substitute them in here. So the sample mean is 25 and the population mean is 27. The population mean is what is stated in the claim. Okay. 27 divided by the standard deviation is 7. We substitute divided by root n, which is 100. So when you put this on your calculator, you get negative 2.8571. We are getting a negative answer because the sample mean is less than the population mean. So the computed test statistic will be what? Option D, negative 2.8571. 34. The p-value for the test is, now here to find a p-value, we will go and check the computed z-score on the table. Okay, so it is 2.8571. So we can approximate it to 2 decimal places, and that will be 2.86. Okay, so we go to the table and then check 2.86. Though it's a negative answer, but you can check it at a positive table in hypothesis test. You can just check it at the positive side. Okay, so 2.86. So this is 2.8. Then let's look out for 6. 0, 1, 2, 3, 4, 5, 6. It gives us 0.9979. Now, because you are using the full table, you take 1 minus 0.9979. You get 0.0021. Okay. Now, to those using the half table, let's also check yours. 2.86. 0, 1, 2, 3, 4, 5, 6. You also get 0.4979. When you also subtract yours from 0.5, you get 0.0021. So you go back to the question and then see. Now you see that we have 0.0021 here. It doesn't mean your answer is correct. Please look at the question if it is one-tailed or two-tailed before you choose the answer. Now when you look at this question, you see that you have not equal to sign at the alternate, which shows that it is a two-tailed test. So because this is a two-tailed test, you won't choose A. You multiply the 0.0021 by 2. So when you multiply it by 2, you get 0.0042. So the correct answer is C. If it were to be a one-tailed test, you choose A as the answer. There is a two-tailed test, so you multiply it by 2. Okay. 35. At a 0.05 level of significance, you can claim that the average of this population is. Now, they say add the 0.05 level of significance. Now, compare this 0.05 level of significance to the p-value of 0.0042. You see that this p-value of 0.0042 is less than the significance of 0.05. So because the p-value is less, then we are going to reject the null hypothesis. So we are rejecting this null hypothesis. Now, when you reject the null hypothesis, it means that you are rejecting the statement that the mean is 27. And it automatically means that you are accepting that the mean is not 27. Okay. So when you check the possible answer, it says A not equal to 25, B equal to 25, C not equal to 27 and D equal to 27. So it means you are trying to say it's not equal to 27. So the answer is C. So let's proceed to the next question. For a highly publicized murder trial, it was estimated that 25% of the population watched the proceedings on TV. A statistics student felt that this estimate was too small for his community and decided to do a hypothesis test. He selected a random sample of 100 residents from the university community where he lives and found that 32 of them actually watched at least 3 hours of the proceedings. So you are answering question 36 to 40 with this. Now to solve this, 36 says the appropriate set of hypotheses for the test is, so to write a null and alternate hypothesis, first we write H sub 0 and bring a column. Then we write H sub 1 with our column. Then we go back to the question. It says it was estimated that 25% of the population watched the proceedings on TV. A statistics student felt that this estimate was too small for his community. So if the stat student think it's too small, meaning he's trying to say that it is actually more than that, isn't it? And more than means greater than. Okay, so when he thinks it's too small, he's trying to say it should be more than that, or it should be greater than that. Okay, and more than or greater than is a statement of inequality. So because it is inequality, we write it for H sub 1. So we write what? P more than 25%. Okay, so greater than 25%. 25% is 25 divided by 100, and that's 0.25. So what's the opposite of greater than? It is less than or equal to. So we have P less than or equal to 0.25. So when we check the possible answers, so the correct answer for this will be D. Then 37. The computed test statistic for the test is, now to find the test statistic, this is a proportion question. So we are going to call the Z formula for proportion, which says P hat minus P divided by square root of P times 1 minus P over N. What was stated in the hypothesis is the P, but the P hat should be from the sample. For instance, they said he selected a random sample of 100 residents from the university community where he lives and found that 32 of them actually watched at least 3 hours of the proceedings. So what will be the sample proportion? The sample proportion should be the number who watches, which is 32, divided by the sample size of 100. So 32 divided by 100 will give you what? 0.32, isn't it? So we substitute everything here. So we have 0.32 minus 0.25 divided by square root of P, which is 0.25, multiplying 1 minus P over what? N, which is 100. When you put this on your calculator, you get 1.6166. So the test statistic is positive 1.6166. Okay, so the correct answer is A. Then 38. The p-value for the test is, now to find a p-value, you can convert a z-score to 2 decimal places. So that would be 1.62. So we go to the table and then check 1.62. So we look out for 1.62. So 0, 1, 2. So 1.62 give us 0.9474. So you take 1 minus 0.9474, you get 0.0526. Okay. To those using the half table, when you also check 1.62, you get 0.4474. Subtract yours also from 0.5, you get 0.0526. Okay. So our answer is 0.0526. The first check if it is one-tailed or two-tailed. So when you come to the alternate part, you see that you have greater than sign there, which means one-tailed test. So because it is a one-tailed test, you choose the 0.0526. If it's a two-tailed test, you multiply the 0.0526 by 2 to get your final answer. Okay. Then 39. At a 10% significance level, 10% also means alpha equals 0.10. Okay, 10% means 10 divided by 100. You can claim that the proportion of viewers in this community was, now to answer this question, what you do is that You take your p-value from question 38, which was 0.0526, and then compare it to this significance of 0.1. You see that the p-value, which is 0.0526, is less than the significance of 0.10. So because the p-value is less than the significance, we are going to reject the null hypothesis. Now, when we reject the null hypothesis, then it means that we are saying it is more than what? 25%. Because when you go back to the null and alternate hypothesis, the null says it is less than or equal to, and the alternate says it is greater than. But since we've rejected the null hypothesis, because the p-value is less than alpha, then it means we are supporting H1, which says p-value is greater than 25%. So because of that, we are going to choose option D, which says it is significantly greater than 25%. Question 40. The standard deviation for the distribution of the sample proportion is, now to find the standard deviation, the formula is square root of n times p times q. Okay, so our n from the question, the sample size is 100. So we substitute it there, times the proportion p is 25%, which is 0.25. Okay, and then the q should be 1 minus 0.25, which is 0.75. So when you put this on your calculator, square root of 100 times 0.25 times 0.75 will give you positive 4.33. So the correct answer for question 40 is C. 41. If two large samples are selected independently from two different populations, the sampling distribution of the difference of the sample means, the answer should be C. Okay, has a distribution that's approximately normal. Okay. 42. If we are trying to establish that the mean of population 1 is greater than the mean of population 2, the appropriate set of hypotheses is, now to write this, first you write H sub 0 and bring your column, okay? Then you write H sub 1 and bring a column. Then you go back to the statement. It says the mean of population 1 is greater than the mean of population 2. Now to write this, greater than is a statement of inequality, isn't it? So because it is a statement of inequality, we should write it as H sub 1, okay? Now, when they say mean of population 1, it means mu 1 is greater than mean of population 2, which means mu 2, okay? So to write that at the alternate hypothesis, we write mu 1 is greater than mu 2. Do you get it? So what is the opposite of greater than? It should be less than or equal to. So we write mu 1 less than or equal to mu 2. Okay. Now, after writing this, then you go and check the possible answers. Now you see that the possible answers doesn't really look like your answer. The reason is that they brought everything to this side. So let's do that too. When you bring mu 2 to this side, it is you group like terms. It is a positive here. When you bring it to the side, it becomes mu 1 minus mu 2 is greater than 0. Because when you lift this to this side, you have 0 here. And then when you bring this also, you have mu 1 minus mu 2 is less than or equal to 0. So your answer should be mu 1 minus mu 2 less than or equal to 0. And mu 1 minus mu 2 greater than 0. So the correct answer for question 42 is D. Mu 1 minus mu 2 is less than or equal to 0 versus mu 1 minus mu 2 is greater than 0. 43. If you are trying to establish that the mean of population 1 is not the same as the mean of population 2, the appropriate set of hypotheses is, now to write this also, we write H sub 0, then we bring a column, then we write H sub 1 with a column. Okay, so you come back to the statement and check. It says the mean of population 1 is not the same as the mean of population 2. When we say something is not the same, it means it's not equal. Okay. When they say something is not the same, it means they are not equal. So, not equal to is a statement of inequality, isn't it? And it should be written as what? H sub 1. So we say mean of population 1, which is mu 1, is not equal to mean of population 2, which is mu 2. So what is the opposite of not equal to? It should be what? Equal to. So mu1 equals mu2. Now you can rewrite this by bringing the mu2 to this side. So when you bring positive mu2 to this side, you have mu1 minus mu2 equals 0. And when you bring this one to, you have mu1 minus mu2 is not equal to 0. So you go and check the possible answers. The answer is B. Okay, mu1 minus mu2 is equal to 0 versus mu1 minus mu2 is not equal to 0. 44. Commuter students at a certain college claim that the average distance they have to commute to campus is 26 miles per day. A random sample of 16 commuter students was surveyed and yielded an average distance of 31 and a variance of 64. The test statistic for this test is, now to find the test statistic, you need to know whether you are using Z or T. Now, to know whether it is Z or T, first let's check the sample size. It's a random sample of 16, so you can see that the sample size is less than 30. So for this, you can actually tell whether it should be Z or T for now. Let's go and check the standard deviation as C. Now it says a random sample of 16 students surveyed and yielded an average distance, meaning the sample gave an average, which is mean, of 31 and a variance of 64, meaning it is from the sample of 16 that we got a variance of 64. Okay, we got this variance of 64 and this mean of 31 from a sample of 16. So because we got it from a sample of 16, it means it's a sample variance. So because it is a sample variance, you can also convert it to sample standard deviation by taking the square root of it. So because it is a sample variance also, at the same time, the sample size is less than 30, we are going to use T, not Z. Okay, so we recall the formula for T. It's also x bar minus mu divided by sample standard deviation over root n. So let's substitute in. So our x bar is 31, so we put it there. And then the mu is 26 divided by, so a sample variance of 64 was given, so we can convert it to sample standard deviation. Okay, so square root of 64, you know the variance is 64, so square root of the variance will give us standard deviation, which is here, divided by root 610. So when you put this on your calculator, you get positive 2.5. So the correct answer for question 44 is C. Question 45. For a small sample left tail test for the population mean, the sample size was 18 and alpha equals 0.01. The critical value for this test is, now to find the critical value here, we are going to use the T table. Okay, now the question has given us the sample size to be 18 and alpha to be what? 0.01. Now before you can find the critical value, first you need to find something we call the degree of freedom. Okay, now degree of freedom in this particular statistics, okay, the degree of freedom is n minus 1. So what is your n? N is the sample size, which is 18. So 18 minus 1 will give you 17. So the degree of freedom here is 17. Then you take the alpha. Now, before you go to the table, check the question if it is one-tailed or two-tailed. The question says for a small sample left-tailed test. So anytime a question says left-tailed or right-tailed, you should know it's a what? It's one-tailed. Okay. If it says two-tailed, then it's two-tailed. Okay. So this is one-tailed test. And the degree of freedom is what? 17. And the alpha is 0.01. So we go to the table. Now, the alpha is 0.01, isn't it? So we look for 0.01 at one tail because it is a one-tail test. If it's a two-tail, we look for it on the two-tail line. There is one tail, so we look for it on one tail line. So 0.01. So this is 0.01. Then we match it against the degree of freedom of 17. So when we trace it down to the degree of freedom of 17, we get 2.567. Okay, we get 2.567. Now, because it is a left tail test, you negate your answer. So the correct answer is D, negative 2.567. Okay. If it were a right tail test, you leave your answer as positive. Question 46. Here too, they've given us sample size, mu and x bar. But this time around, you see that it looks like one of the questions we've solved in the past. But this one is not a sigma square, it is rather S square, which is sample variance, meaning we can get a sample standard deviation from here. Now, here are we using Z or T? To know whether to use Z or T, check the sample size and the standard deviation. Now, when you look at the sample size, this sample size is less than 30. At the same time, the population standard deviation is not known, meaning that it is a sample standard deviation that we know. Okay, so whenever you have a sample standard deviation or variance, at the same time, the sample size is less than 30, you use T. Okay, so you record a T formula, which says x bar minus mu divided by sample standard deviation over root n. So we substitute into the formula. So x bar is 16 and the mu is 15 divided by S square means sample variance. So you can find sample standard deviation from it by taking the square root of it. So square root of 16 is what I've written here, divided by the square root of the sample size, which is 16. So root of 16 goes into itself once and goes here once. 16 minus 15 is 1. 1 divided by 1 is positive 1. So 1.00. Please, you won't choose A because you are computing T, so it should be T equals 1.00. Okay. 47. For the following information, n equals 16, mu equals 14.239, x bar equals 16. You see that the variance is sample variance. At the same time, the sample size is less than 30. So because the sample size is less than 30, at the same time, the variance is a sample variance, or the standard deviation is a sample standard deviation. Because of that, we are going to use T. Okay. So to do that, we record the formula for the T. That T is equal to x bar minus mu divided by sample standard deviation over root n. So we substitute. X bar is what? 16 minus the mu is 14.239. To get the sample standard deviation, we take the square root of the variance. So square root of 16 divided by square root of n. So when you put this on your calculator, you get 1.761. Okay, so 1.761. The question is asking us for p-value rather. So to get a p-value, we go to the T table. Now in T, to find a p-value in T, this is what we do. You take the sample size and then find the degree of freedom. So the degree of freedom will be 15. Then you go to the degree of freedom and go and look for 1.761 on it. When you go to the table, now when you check the degree of freedom of 15, trace it to this side and look for 1.761. Now you can see that 1.761 is not on it. It will be between 1.753 and 2.131, isn't it? Now the question also says right-tailed. It means it's a one-tailed test. So we trace it up to one tail. On one tail it will be at 0.025, and this one too on one tail it will be at 0.05. So you say that the p-value is between 0.025 and 0.05. But here you can just choose B as your answer. P-value equals 0.05. The reason is this your 1.761. When you check it, you see that it's more closer to 1.753 than 2.131. Yeah, that's why you choose that of the 1.753, which is 0.05. So the correct answer is 0.05. 48. An advertising agency would like to create an advertisement for a fast food restaurant, claiming that the average waiting time from ordering to receiving your order at the restaurant is less than 5 minutes. This agency measured the time from the ordering to delivery of order for 25 customers and found that the average time was 4.7 minutes with a standard deviation of 0.6 minutes. The test statistic would be computed is, now to find the test statistic, first you have to identify whether it is Z or T. Okay, so when you look through the question, you see that they said the agency measured the time from ordering to delivery of order for 25 customers. That's the sample size, 25. It's less than 30, number one. And also, and found that the average time was 4.7 minutes with a standard deviation of 0.6 minutes. When you look at this, you see that the standard deviation is also a sample standard deviation because it's referring to this sample size of 25. So because you have a sample standard deviation at the same time, a sample size less than 30 at the same time, then you are using t. So the formula for t is, so you have x bar minus mu divided by sample standard deviation over root n. So what is our x bar? Our x bar is 4.7 from here. That's the sample mean. And the population mean is 5 from here. Divided by sample standard deviation, which is 0.6. Then we divide it by root 25. So when you put this on your calculator, you get negative 2.5. So the correct answer for this is negative 2.5 or negative 2.50. Okay. Question 49. If we are testing for the difference of two population means, the pooled variance is appropriate if the correct answer is D, or the above. It is appropriate if the populations are normally distributed. It is also appropriate if the sample sizes are small, and it's also appropriate if the population variance are unknown but assumed to be equal. So the correct answer for question 49 is D. Question 50. If a null hypothesis is rejected at 5% significance level for a right tail test, U, the answer should be A. 5% means 0.05. Whenever you reject a particular hypothesis at a particular level of significance, then it means that you are going to reject it again at a level of significance greater than that particular level of significance. The other level of significance less than it, you can't tell whether you reject it or not. So when you look at 5%, which is 0.05, you see that 0.01 and 0.06 are less than it. So for those ones, you can't tell what to do. But it is certain that all level of significance that will be more than this particular level of significance, you still reject it. So that is why the correct answer for question 50 is A. Okay. You can also check the description area below for the link to question video on normal distribution, Poisson, binomial, confidence interval, sampling distribution and central limit, and the others. So I'll end this here for now. Thank you.